All right, so let's look at polynomial division. And there's two types of polynomial division we're going to look at. The first type is long division. And kind of get an idea how this works. Let's go a real quick review here. And let's say we were asked to write 371 over 5, 371 fifths as a mixed number. Okay? And so what I'm going to do is I'm going to divide 5 into 371. And so I'm going to say, well, 5 doesn't go into 3, but 5 goes into 37. 7 times 5 times, or 7 times 5 is 35. Subtract, I get 2, bring down the next digit. And I do that again. 5 goes into 21 4 times. That would be 20. 4 times 5 is 20. Then I'm going to subtract and I'll get 1. And now I have a remainder of 1. Well, what that tells me is 371 over 5 is 74 wholes, goes in there 74 complete times, and then I have 1 left over, so I have 1/5 remaining. So 75 whole parts and 1/5 pieces. Now when we write 74 and 1/5, we don't mean that's 74 times 1/5. I mean, in algebra, a lot of times things touching means multiplication. This actually means 74 plus 1/5. And this process that I've just done is basically what we're going to do when we look at regular polynomial long division. Obviously, it's going to be a little bit more complicated, but the general idea is the same. We're going to have to, when we write our answers, we're going to be more like this second way of writing, the 74 plus 1/5. By the way, in some calculators, if you want to put a mixed number in there, this is how you have to put it in there, because that's what it really means. All right, so let's look at what polynomial division. So let's say we want to do, let's say divide, and we had 5x cubed minus 2x squared plus 3x minus 1, and I'm going to divide that by x squared minus 5. Okay? So, just like in the previous example, I'm going to put my divisor out front here, and I'm going to put my dividend inside my divide symbol here, 2x squared plus 3x minus 1, and what I'm going to try to do is how many times does this go into this. Now there's a lot of information here. It's too much for me to process all at once, so instead I'm going to break this up into steps, and I'm going to say, I'm going to look at the first term of my divisor, x squared, and I'm going to ask myself, what do I need to multiply this by to match the first term in my 5x, my dividend, my 5x cubed? It'd be a 5. I need to multiply by a 5, but I also need another x in order to raise this up to x to the third. Now, where you write that, some people have different choices. I'm going to write it over here for 5x so that I put it over the x term. But some people like to write it over the term they're trying to match. And ultimately, it's up to you where you want to write it. I personally find this makes more sense, putting it over the x term. If you think about how you do normal division, you always write the number over the last term you're working with on a step. And it has to do with place value and things. But ultimately, for this, it's not that big a deal. So now what we're going to do is, just like in the previous example where we took 7 times 5 and got 35, you took the number up there times the divisor and you got this product here. That's what I'm going to do here. Is I'm going to take 5x times everybody out front. So I'm going to take 5x times the whole x squared minus 5. Now notice, even though I was only trying to make the fronts match, I still got to work with everybody. There's certain parts we're focusing on, but we have to make everybody work. So 5x times negative 5 is negative 25x. So I need to put that over here. And you'll notice I had to skip over this middle spot. Well, that's, if you look at this x squared minus 5, notice I don't have an x term. So I'm already skipping a term, and that's what's happening here. It's exactly what we would expect to happen. And then, just like in the previous example, we took 7 times 5, we got 35, and then we subtracted. Well, with polynomials, we don't tend to talk about subtraction. We talk about adding the opposite. So I'm going to change both signs. I'm going to change this to a negative 5 and that to a positive 25. And then combine like terms. So positive 5 and negative 5, those cancel out. This middle term just drops straight down. 3x, now positive 25x gives me a positive 28x. Then I bring down the next term. And I start the process over again. I ask myself, what do I multiply x squared by, this leading term in the divisor, to match the first term down here, negative 2x squared? Well, I got the x squared part covered, but I need this negative 2, so I'm going to multiply by a negative 2. Remember, you always start by matching. Make it perfect. So I'm going to take negative 2 times x squared minus 5, my whole divisor. Again, negative 2 times x squared, negative 2x squared. Negative 2 times negative 5 is a positive 10. Again, notice I skipped over that middle spot. Which is exactly what I would expect if I'm missing a term here. And then we subtract, or we add the opposite. So change those signs. Negative 2, now positive 2 cancel each other out. I get a 28x, drop straight down, minus 11. Now this has a lower degree or lower power than my divisor. This is the remainder. So our answer here, what we get is the quotient, 5x minus 2, plus the remainder, this 28x minus 11, divided by my divisor, x squared minus 5. This is just like in that first example we did, where we got 74 and 1/5, or 74 plus 1 divided by 5. So our quotient plus our remainder over our divisor. That's exactly what happened here. We got our quotient plus our remainder over our divisor. Let's say we wanted to divide 5x cubed minus 4x squared minus 15x plus 12, and we're going to divide that by 5x minus 4. Okay, so 5x minus 4 into 5x cubed minus 4x squared minus 15x plus 12. Oops, think about, well. Alright, let's try that again. Plus 12. Okay, so what do I need to multiply 5x by to get 5x cubed? Get x squared. So x squared times 5x minus 4. That gives us 5x cubed minus 4x squared. Change the signs. And those all cancel out. We get zeros and zeros, okay. So they're gone. So what do? Well, I bring down the next two terms. Normally I bring down one term, but because all of this came out to be 0, and I'm working with two terms in my divisor, I'm going to need two terms here. So what do I multiply 5x minus 4 by, or what do I multiply 5x by to get negative 15x? And the answer would be negative 3. And you notice I skipped over a spot. That's because we skipped over one of the products we were going to get. So negative 15x plus 12. Change the signs. Remainder of 0. What does that tell me? Well, it tells me my answer is x squared minus 3, It also tells me if you take x squared minus 3 times 5x minus 4, you will get this polynomial, 5x cubed minus 4x squared minus 15x plus 12. Okay, let's do one more long division. Let's say we divide by, we have x cubed minus 8, and we're going to divide that by x plus 2. Okay? So I'm going to say x plus 2 is my divisor. My dividend is x cubed blank blank minus 8. Now, what I'm doing here is, you'll see I have the third power, I have the constant, but I don't have a second power or a first power. So if you're missing some powers of your variable, you should leave room for them, because they may show up in the problem, and a lot of times they will. What some people like to do is they like to say a plus 0x squared and a plus a 0x. I don't make the recommendation that you do that, though you can, and that's perfectly fine. But I've seen people treat a 0x squared as instead x squared or a 1x squared. So that's why I usually recommend you just leave room for it for now. And if it shows up, great, and if it doesn't, you don't have to worry about it. So what do I multiply x by to get x cubed? I need an x squared. Again, take x squared times x plus 2. That'll give you x cubed plus 2x squared. Change the signs. That gives us negative 2x squared. Again, normally we bring something down here, but we don't have anything to bring down. So what do I multiply x by to get negative 2x squared? A negative 2x. So negative 2x times x plus 2 gives me negative 2x squared minus 4x. Change the signs. Let's both become positive. It becomes a 4x. Bring down the constant. What do you multiply x by to get 4x? And that would be, you need a positive 4. So 4 times x plus 2. So 4x plus 8. And change the signs. And you get negative 16. Now, when I write my answer here, I have two options. There's the first option, and that is just to say this is plus negative 16 over x plus 2. And this is the option I would recommend you take. The reason why is if there's more than one term on the top, what we're going to see, the other way to do this, changing the signs, you can sometimes make an error. So the other way you could do this is instead say, minus 16 over x plus 2. Since the 16 is negative, you could use that negative there. Again, I wouldn't really do that if it was up to me for my recommendation. If you're comfortable enough with control of your signs, great. That's a great way to do it. It makes things nicer, but ultimately, I don't want you to miss the problem because of a sign issue. So it's easier just to, always say plus and then just put the remainder on the top, whatever it is, and over the divisor, and then worry about it. Okay, so that's the first type of division. The second type of division is synthetic division. Okay. The problem with synthetic division is this only works when the divisor is x plus a number or x minus a number. If it's not that, you can't use synthetic division. So anytime I said I was dividing by something like x squared, so here, let's look at these examples. Like this one, I was dividing by x squared minus 5. I can't do synthetic division with that. This one, I was dividing by 5x minus 4. As it's written, I can't do synthetic division with it. Now, I could take both the divisor and the dividend and divide everybody by 5 and make this divisor x minus 4/5, and then I would be working with fractions, but then I could do the synthetic division. So if the coefficient's wrong, you can fix that, but like in this first one where it's x squared, if it's a power higher than 1, there's nothing you can do there. This one I could have done synthetic division. And maybe I'll do that. I'll show you how to do this. So let's say I'm going to do that last division problem again, but this time I'm going to use synthetic division. So x cubed minus 8 divided by x plus 2. Okay? So this is how it works. What you do is you say, what is the 0 of the divisor? So what makes this 0? And the answer is -2. So you write that number up in a little box up here. Then you list all the coefficients in order, in the correct order, so highest power to constant, of the dividend. So my first coefficient is a 1, there's a 1 there. And then x squared is a 0, and x is a 0, and then my constant, -8. I'm going to leave myself a blank line here. And so this is how it works. You take that first number, you don't do anything to it, you just drop it straight down. Then you take your little number up, your 0 of your divisor, multiply it by what you got here, and write that answer under the next number. And then you add. 0 plus -2 is -2. And then you do that again. Take your 0 of your divisor, times that. Right in the next spot, -2 times -2 is a +4. And add. And then take your 0 of your divisor, times that, multiply it, goes to the next spot. So -8, -2 times 4 is -8. And you add, you get -16. These are the numbers that go into the answer. So if you look at this, what we're dividing, and you just look at the first term divided by the first term, x cubed divided by x would give you x squared. That's where this one starts. This is a 1x squared or x squared. And then we have the next power of x, so -2x, which brings us to the next spot, which is the constant. And then this number back here, so x squared, x constant, this is the remainder. So plus -16 over my divisor, x plus 2, what I was actually dividing by. And if you look, x squared minus 2x plus 4 plus, that's exactly the same answer we got when we did long division. So this is a little bit simpler. Let's do another one. Let's say we had, we wanted to divide, let's say we had -x cubed plus 7x minus 6, and I want to divide that by, say, x plus 3. Okay? I'm going to ask myself, what makes this, well, actually, let's not do that. Let's do, since we already did a plus, let's do -2. -2. Okay, so what's the 0 here? +2. So I'm going to say 2, go up there. List my numbers. -1. Notice no x squared term, so I need to put a 0 there. 7, -6. Leave myself a line. So you see, if it's an x minus a number, you're going to get a positive number. If it's an x plus a number, like we saw in the previous example, x plus a number, it's going to be a negative number. And what makes it 0? That's what we're looking at here. So, all right, bring this first one down. -1. 2 times -1 is -2. We add, so that's -2. 2 times -2 is -4. Add. 2 times 3 is 6. Add 0. This is the remainder. This drops by a power, so x squared, so -x squared, -2x plus 3. And if you ever, as long as you remember you drop one power, you ever run into a situation where you're like, okay, I got the second power, I got the first power, and you're like, it's just a, maybe I'm missing a number. That might tell you, oh, I didn't put the 0 in there. I need to redo this. Again, remainder of 0, what does that tell me? It tells me if you take this answer and you multiply it by x minus 2, you get negative x cubed plus 7x. And what we're going to use this for is if we can find a factor, in something that goes into a polynomial, then we can divide it out and find something else that goes into a polynomial, and we might be able to do some things with that. We might be able to factor it, might be able to use a quadratic formula, whatever. So that's where we're going to be going with this stuff.